So in this video we are going to discuss trigonometric ratios up to transformations. So page number 283, example 1. So in this, the second bit is we have if ABC are angles of a triangle, then prove that sine 2a plus sine 2b minus sine 2c is equal to 4 cos a cos b sine c. So now here given that in the solution, so ABC are given that, so ABC are angles of a triangle. ABC or angles of a triangle is given. So angles of a triangle means we know that sum of the angles is equal to, so 180 degrees. So A plus B plus C is equal to pi we have. Now given LHS is here, so we have sine 2A plus sine 2B, sine 2b and minus sine 2c here. So if you observe that first two terms are like sine c plus sine d here. We know the formula for sine c plus sine d. So now sine c plus sine d is equal to, sine c plus sine d is equal to 2 sine c plus d by 2. 2 sine c plus d by 2 into cos c minus d by 2. So same like that here, c is 2a and d is 2b. So if you apply the formula, same formula for these two terms, 2 sine 2a plus 2b by 2 into cos 2a minus 2b by 2. So minus sine 2c is writing as it is. So now here, if you take the 2 common in the numerator and numerator, so 2 gets cancelled in the numerator and denominator in both the terms. Now here 2 sine of a plus b, 2 sine of a plus b into cos of a minus b and minus sine 2c here. So now a plus b is equal to, from this we know that, so we have the condition a plus b plus c is equal to 180. So from this a plus b is equal to, we can write 180 minus c. So that's why here 2 into sine of n. So 180 minus c into cos of a minus b and minus sine 2c. So now we know that sine 180 minus theta is equal to, sine 180 minus theta is equal to, we know that sine theta, it is always belongs to the second quadrant. Now same like that, here 2 sine 180 minus c is also sine c here and into cos of a minus b, cos of a minus b minus sine 2c. So now we have the formula here, sine 2 theta is equal to, the standard form is sine 2 theta is equal to 2 sine theta cos theta we have. So now the last term is here, sine 2c is also we can write using that formula. That means which is equal to 2 sine c into cos of a minus b, cos of a minus b and minus sine 2c is writing as like using this sine 2 theta. So 2 sine c cos c. Now if you take in both the terms 2 sine c common, so now 2 sine c into, which is cos of a minus b, and here minus cos c we get, minus cos c. So now again which is equal to 2 sine c into cos of a minus b and here minus cos of the c is replaced by, again from the same condition we can write c is equal to 180 minus a minus b, which becomes 180 minus of a plus b. So that's why here c is replaced by 180 minus of a plus b. 180 minus of a plus b, c is replaced by. So now here, so we have the property that cos 180 minus theta, which is also belongs to the second quadrant. But in the second quadrant cos is negative. So that's why cos 180 minus theta is minus cos theta. So now which becomes 2 sine c into here cos of a minus b and here minus this cos 180 minus theta becomes a minus cos theta. Here theta is a plus b. So that's why here minus cos of a plus b we get. So now which is equal to 2 sin C into cos of A minus B, and this minus into minus is plus cos of A plus B. So if you observe here, this within the bracket we have the two terms which are in the form of standard formula. We have cos A minus B plus cos A plus B, so which is equal to, we have 2 cos A cos B. So cos A minus B plus cos A plus B, or cos A plus B plus cos A minus B, we have 2 cos A cos B. So which is equal to 2 sin C into, this is replaced by 2 cos A cos B, 2 cos A cos B. So which is equal to, we get 4 cos A cos B. If we multiply, we get 4 cos A cos B sin C. So this is only the RHS we have to prove here. 4 cos A cos B sin C. So that's why when ABC are the angles of a triangle, we can prove that sin 2A plus sin 2B minus sin 2C is equal to 4 cos A cos B sin C. So therefore here finally we can say that LHS is equal to RHS. Like this we can prove the problem.